welcome. Thank you for joining us today. My name is Roger Struckoff. I'm the Chief Research Officer and Editor-in-Chief at IDCA. Yes. I thought someone was calling me. We are joined today by Rich Banta, who is our CTO and the chairman of our technical committee. Okay. It looks like for those of you who have already entered, we're going to start this again. We're going to give another minute or two for everyone to join. Wow, I can see the people joining us now. For those of you who have joined, we're going to officially start in about 1 minute, so thank you. Okay, yeah, we've got about another minute to go, Rich, and we can just chat a bit before we get going for those who are here, so they know we're aware of everybody's presence. How's the weather? It's really hot where I am.
I actually have a fan pointed at myself.
Yeah. I had thunderstorms rolling through this morning, which we're going to talk about electromagnetic interference. I was more concerned about the electrical interference, that the storm was going to blow me off the internet, but so far not. Or here. If the storm gets worse and I disappear, everybody, don't worry. Rich can handle this. He's the expert.
We're just headed for 90 degrees and climbing here.
Yeah, same thing. I'll tell everyone where we are, just because they're scattered all over the world. Okay, I think we're ready. Thanks for joining us. Hello, my name is Roger Struckoff. I am the Chief Research Officer and Editor-in-Chief of IDCA, the International Data Center Authority. We are joined today by Rich Banta, who is our CTO and also chair of our technical committee. The IDCA is headquartered in Washington, D.C. area, and we have colleagues and associates and lots of people scattered all over the world. We have people in every region of the world. We have offices in several regions as well. I happen to be on the outskirts of Chicago, and Rich is one state over in this great state of Indiana today. So today we are going to talk about electromagnetic interference and electromagnetic pulse, EMI and EMP. Rich is going to start by talking about something that is very, very routine and of which we all must be acutely aware, and that's EMI from 5G and also sort of poorly earthed data center equipment. And then we're going to move on to high altitude EMP. That's the scary stuff involving possible terrorism. And then we're going to take a short break. And then we're going to finish by talking about something there's nothing we can do about, which is CME. Well, we can protect against it, but we can't stop it, which is CME, the coronal mass ejections. Along the way, we're going to occasionally throw a couple of questions for you to answer. Very simple, yes or no. Sometimes there's a little multiple choice as we find out more about what everyone does and what your interests are. So with all that aside, let's start. Rich, welcome. Thanks for your time today. Basic question, EMI may seem like an obscure topic, but it's certainly not, and it's certainly common. If you kind of take us through the background and what are the common risks that everybody who's watching this is facing at this very moment.
Yes. And we're all immersed in electromagnetic interference, and it seems to be more so all the time. With the 5G, I recently upgraded to a 5G phone, and to upgrade an app on my phone was 170 meg, used to be a 10-minute endeavor. Now I watch it happen in a matter of 10 seconds. That is an awful lot of radio frequency surrounding me, no matter where I am in the house.
Yeah.
There's very few places you go that don't have Wi-Fi, and everything is Bluetooth connected. So we have all these different spectrums around us. They affect us as organisms, but they also affect our data centers. And within the data centers, even within a co-location data center, we want all the comforts of home. So in my co-location facilities, I'll have 60 customers, some of them just in 10 by 10 and 10 by 20 foot cages, and each one of them will have their own Wi-Fi network. Okay. So you will walk through there with the scanner and see all of these. So you're bathed in all of that, but worse yet, as far as somebody gets compromised in that environment, it's a terrible idea because you have unlimited time on target on your neighbor's Wi-Fi network. But also within the data center, and I'm guilty of this, a data center is a huge edifice of concrete and steel. It soaks up radio frequency energy and it deflects it. And any data center I'm auditing that's worth its salt is going to have a well-earthed raised floor support grid and a signal reference grid under that or above our heads, which soaks up more signal. Well, that harshes our cellular phone buzz. So guilty of this myself. I wanted to be able to use my phone anywhere in the place. So we had a whole bunch of 4G repeaters and amplifiers installed throughout. Just anything we had managed to deflect, absorb, or get rid of, we reinstated on our own, and everybody does that with 5G as well.
Well, one thing I heard you mention before when I was listening to you speak was with 5G, still relatively new, and there's some spectrum issues that maybe we did not have before.
There are. 5G is a wide variety of spectrums, and I'm an old radar troop from the Air Force, and they told us this non-ionizing radiation could never harm us. We're not going to go down that rabbit hole, but it has been proven to affect DNA. And 5G, as radar frequencies went up and abandoned some of the lower spectrums, 5G has stepped into those.
Yeah.
And they're driving down the streets of beautiful Carmel, Indiana here. I see a 5G repeater cleverly disguised as a light pole every quarter mile at the least. It's everywhere.
So, I mean, compared to say 5 years ago, if you look 5 years out from now, just the sheer amount of EMI is going to increase by a factor of what? Double, 10 magnitudes? I mean, it seems like it's going faster than we could imagine.
I've read a magnitude of 4 to 5.
Yeah.
And we're not seeing a lot of effects of this in the data center.
Yeah.
But are some of the common practices of 2-post relay racks without earthing every cabinet within that, some of those practices are going to have to fall by the wayside.
So some of those practices are prevalent in what percentage of data centers that have already been built?
Gosh. In any carrier hotel, it is still, I've watched brand new carrier installations done within the last 6 months where they're still using 2-post unenclosed cabinets. They're not individually earthing the pieces of equipment within those. Modern best practice is to put it in a fully enclosed cabinet, individually earth every piece of equipment to the cabinet, which is well earthed, etc.
No, I've read it could take you maybe a few millions of dollars to properly insulate yourself. But it reminds me of the old commercial that people of a certain age watching this will remember, which is you can pay me now or you can pay me later. And it sounds as if there are going to be consequences here. at the top, I was thinking consequences to the infrastructure, potential consequences to deleting data or disrupting data. But the third thing that you're mentioning is also just to we humans. So it looks like there's three areas in which EMI is a big issue.
Yeah, and the threat to humans is it. I don't know if it should be controversial or not, but it is. If you step too far down that, you get called a conspiracy theorist, or I've been called worse. But I believe there's a legitimate concern there.
Yeah, well, I'm from Illinois, so they call me a Bears fan sometimes. So that's the worst thing I can imagine. But the thing is that we go to the infrastructure and the data. I mean, what is the certitude that if you're really poorly earthed, if you're not protected, that something is going to happen, even if it, whereas a friend of mine says, what is happening that you're not aware of?
At a minimum, you're going to see corruption of transmitted data, anomalies in the data, and the least harm that's going to cause is a lot of dropped packets and retries. But the biggest, at worst, it's going to cause corruption of stored data.
Now you're getting into, even slower performance. You can risk violations of SLAs, which is something that maybe is strictly engineering people are not that concerned about, but it's a huge effect on the business. Suddenly you're just not performing the way you should. You may not meet an SLA, and there are consequences to that. That's what it sounds like to me. Where should people start? You mentioned hotels, you mentioned some facilities you audit, you travel around a lot. How do people get a handle? How do they get a start? What should they look at? And where should they start to address these issues?
If your organization isn't large enough to have an assessor on site, somebody that has EMI measuring and reference equipment, knows how to use it, and knows how to interpret that data, I would bring in somebody that does.
Yeah, such as yourself, but there are other people.
I know a guy.
Yeah. But what are they going to look for? What is the kind of process that you start with anyway?
They're going to baseline your EMI environment, just how much is out there and at what frequencies, and put those against IDCA 64,000 guidelines for what's acceptable, how much it's safe to have around various flavors of equipment, data communications equipment, server equipment. It's published, but somebody has to gather the data, gather it properly, filter it, and know what they're looking at.
There's you sit on a lot of different. You're the chair of our technical committee at IDCA, but you have sat or sit on a lot of different committees and organizations. What are some of the big standards, protocols, specifications with which you've dealt recently, and why are they important? And it's okay if we do a little alphabet soup here, because everyone has to learn it if they don't already know it.
Not entirely related to this. I sit on an IEEE committee for medical devices. The cybersecurity of IoT, Internet of Things, medical devices is nascent. It's completely the wild west. You can buy a medical device which critically affects life safety, truly life and death, and there's no way to update it if a vulnerability is found and published. I recognize that as a shortcoming, and was happy to get onto that particular committee. And then the IDCA standards committee, technical standards committee, there are solid data center standards out there from the 1990s. The ANSI TIA standards, BICSI, and ISO standards for data center construction operations and such, but they are mired back in telecommunications, electrical, architectural, mechanical, or team. And an application delivery ecosystem is composed of so much more these days.
Well, the medical devices, actually, it's, I guess, not really a peripheral issue, because they generate a lot of data today, and oftentimes in networks. I was actually involved in a project where it was the systems that put the drugs in the IVs, and you like to have a whole inventory management, and they're taking readings every 10 seconds, and it's a lot of data. And you did not want those disrupted, especially in a intensive care setting. So I think the potential for disruption of medical devices leads to the potential for disruption, I think, for a lot of
And
people.
most medical devices, the IoT things, IV pumps and whatnot have batteries, and they connect to the network wirelessly. Most everything most all new devices out there do. So now EMI does come into play. If it disrupts those, now you're into a life safety situation.
Okay, we're going to throw a question up here. We're going to keep on talking, but we have a few simple questions we'd like to ask people. So we'll go ahead and put one there and go ahead and answer it. And Rich and I'll we'll keep on conversing as we go through the different questions. Again, so let's say we're building a new data center, whether it's very people still doing smaller building type things, or whether they're building something massive. Where I live on the outskirts of Chicago, we've got a couple of massive ones going up right now. One, and it's public information, one from Facebook, and they're pulling tens and tens and tens, dozens of megawatts. And so as they're doing that, do you think, what are the concerns about EMI? We're not going to speak for Facebook what they may be doing or not be doing, but are there people that are still building something on that scale without really doing what you think they ought to do?
The majority of people I interface with in the industry are still working without it. And it is very difficult to retrofit. It needs to be thought out and done before you get your financing, because it's very expensive, and before you pour your concrete, because there's no one doing it after that. It's a very difficult retrofit, almost impossible.
We just asked our audience, does your organization have an EMI, EMP protection strategy and plan? And guess what? 71% said no. So you're validated in real time. And we can go ahead and ask a follow-up to that at this point as well. Would be fine to do that.
I'm surprised that 29% said yes.
Well, there you go. There's the silver lining in a way. And what we did not do, and what we'd encourage our attendees to do is, contact us with detailed questions, because that was just a yes or no question. It spoke not to the quality, rigor, budgeting, truly, extent of the strategy. So that 29%, it may not be as good a news as you think. We're asking now whether, do you think your digital infrastructure might be currently at the risk of or exposed to EMI? And they're answering very quickly. The poll is about complete. And yeah, 2/3 say yeah. So we've got pretty good split there. Same percentage is saying, yeah, we could have some trouble here. We're going to move on pretty soon, I think.
We do have a question that popped up in the Q&A.
Cool.
And the question is, does it matter the size of the data center in regard to EMI? It is obvious hyperscale and colos have these concerns. What about the smaller footprint enterprise DCs that are still out there? Size is simply a question of economy of scale. And when you get into hemp protection, it's very difficult to do in a multi-story data center facility, not a multi-story building, but with a multi-story data center envelope. But the increase in expense and complication is simply, it's linear. It's just economy of scale.
Like to move on to hemp, or do we have a little more we could talk about with the basic 5G stuff? I'm ready to move on to hemp if you are.
I'm ready.
Let's do it. Now we're going to take a little break in the midst of this conversation, and it'll be 5 minutes, and we will be back in 5 minutes so that we don't waste anybody's time. Theory affects the fences. Let's define very specifically. Hemp, I think, is high altitude EMP. And there's some history there, and I think it's okay to tell us the history a little bit, and without giving us too many nightmares, let's talk about hemp. Tell me.
Sure.
This is something you've written a big paper, a dissertation on, so this is.
I have, and there's a journey behind that. To
Yeah.
anonymous question there, fly, fight, win, go Air Force. But
You don't have to read every question, including. Okay, let's start some inter-service rivalry here.
My hemp journey started. I was speaking at an AFCOM data center world at Las Vegas in 2015.
Yeah.
And we had just purchased a building in Fort Wayne, Indiana, 84,000 square feet, and we were ready to roll with construction. And I sat through a hemp presentation at Data Center World given by my good friend Michael J. Caruso. And I called my business partner from the lobby of the Mirage and said, "Stop the bulldozers. We want to look into this."
Wow.
It seems worthwhile. And I eventually wound up being a panelist and speaking on the subject myself, and got to hang out with people involved in critical infrastructure and such things, and sit around dinner conversations, which just the more you sat in them, the scarier they became. And so we revamped the data center, came up with a plan, found out the US government knows how to do it, and they don't share how to build such a shield. There are some credible manufacturers of shields out there, but it increased expense 16-fold to enclose the entire facility, to include HVAC generators and everything else. It all has to be protected. And then in pursuing my data center authority designation with the International Data Center Authority, you have to write a thesis, and I was tasked with writing a thesis on hemp and coronal mass ejection, or GMD, geomagnetic disturbance protection. Many hundreds of hours of research. We had to redesign our shield and protection mechanisms twice as I rolled along and learned. I got to interface with some great minds out there. Mike Caruso comes to mind. Dr. William Brodasky, who is a pioneer in EMP theory, he did work on Starfish Prime in 1962 when the phenomenon was first really identified. And I just love doing this stuff because it kept taking you down rabbit holes. You have to carry away all this current. You can only do it using certain metals, but now you have metals with highly disparate nobilities that instantly in contact create galvanic corrosion. And in reading the paper, I kept going down these rabbit holes and areas of study I never thought I would be in, and to this day still go there.
These are good rabbit holes. I mean, these are rabbit holes that could be consequential, I think. I mean, how real are these threats?
The hemp high up, we're talking about a thermonuclear device detonated 100 miles up in the atmosphere. Okay. And the likelihood is very low. The impact is unbelievably high.
I mean, we've been living with this existential threat for decades, and it's no less than today than it's ever been. So, right.
I think it's more likely than ground burst nuclear devices. If either one happens, we have some really big problems in front of us. And I mean, the grid's going to collapse. A black start has never been attempted of the entire grid, once you sector out what parts of it have been destroyed. And the predictions in civil defense circles, in a complete collapse of the grid unrestored, 90% of the US population would perish within 12 months. That's highly contested and disputed, but that is most often what you hear. But if you're building an EMP protected facility, it is not to sustain uninterrupted operations should this go on. This is to protect the jewels, healthcare data, financial data, and post 9/11, many of those entities are protected with the assistance of the US government. We are out there working on it in the civilian world. The technology was so nascent, we had to roll our own, if you will, and I'm actually co-inventor on a patent for a process to build a shield that does not multiply your build out expense by a factor of 16,
16,
only by a
okay.
factor of 2 or 3.
What, 2 or 3? Well, it's whatever that is. What, let me do my quick calculation. It's at least an 80% savings. Put it
Yes.
that way, 80 to 90. And we have some slides. Would you like to show some of those slides now, or shall we wait till after the break? Yeah.
I think we can start
Okay.
with the, let's start with the diagram of a EMP pulse.
The wave,
event.
the wave
Yes,
diagram.
an EMP wave. And
This is
it
pretty
comes
intense.
in 3 sections.
And as I understand it, you've got, I was trying to wrap my mind around it, and it'll come up here soon enough, I think. But you're measuring things in picoseconds, nanoseconds.
Nanoseconds. We have gone a long way to the other side of the decimal point. And the electrical theory here is not Ohm's law. This is time domain and frequency domain. So the left side of the chart is power in volts per meter, the vertical plane. The horizontal plane is time in seconds.
So 10 to the minus 10 is a pico.
Yes. E1 is the initial, when the air burst of a nuclear weapon goes off, it shoots out gamma rays. These interact with electrons in the upper atmosphere, which produces electromagnetic energy, and that comes at the speed of light. So if you interpret your 10 to the negative 10th to your 10 to the negative 8th there, that comes out to about 25 nanoseconds.
Okay.
That pulse, to counteract that, we're doing what you would do sitting in your car during a lightning strike.
Mm-hmm.
You want it to couple to your shield and be directed around you.
Okay.
And that has to happen in plus or minus 25 nanoseconds. You will have succeeded or failed long before you have any idea what has happened to you.
Yeah.
The E2 portion is the secondary excited electrons from the gamma strike, exciting other electrons and continuing this electromagnetic energy. E3 is the geomagnetic disturbance that follows it, which is pretty closely related to what we see from a solar flare or a coronal mass ejection. And this is interacting with the magnetosphere, with the mantle, and with the Earth's magnetic. There's a surge and a heave.
Consequences. Yeah, I mean, human reaction time, I think, cannot be quicker than 1/10 of a second.
No, it's over before we know what happened.
Yeah, but then the consequences after that.
So we have a picture of a shield that was meant to absorb, to collect this energy. Could we show a picture of the shield, please?
I think it's the building. Yeah. Maybe it'll come up here.
There we go.
There we go. Look at that. Okay. Tell me what we're looking
that is 2 layers of 26 gauge sheet metal joined, overlapping, glued with highly ferrous glue and taped with highly ferrous tape. There can be no gaps or seals anywhere in that. That is then bonded to the columns. This is an 84,000 square foot facility, and there are 386 8-foot copper sheathed ground rods to try and get all that current to Earth. So after the break, I think we can take a little dive into the math that went into that.
Okay, yeah, and this is, don't try this at home, kids, right?
And that was
people in.
Phenomenally expensive. There were 19 months of trial and error that went into that. We would try a process, send it to lab for testing, fail. And this was a construction project. Every minute of delay is expense. So that this became an endeavor of stubbornness and love before it was said and done.
Okay, we're going to leave you hanging right there. We're going to go to a break. We'll be back at 10:35. We'll have some more poll questions for you, and we already have a pretty good question here that we can address when we come back from the break. So thank you for attending. We'll see you in 5 minutes. Great to see the interaction. And this is great. Yeah, this is one of these things where I'll give us 4 hours. We could. There's so
Oh,
much
golly, the time
going
flew
on.
by.
Yeah.
I was really worried about feeling it. I'm going to get up and
No,
walk
yeah,
about a
go
bit,
ahead.
stimulate
Go ahead,
the
take a
blood flow
break.
here.
I might grab a little more coffee as if I need it. Water maybe. I'll be back too in a couple minutes. So anyone who's listening, as it says right there on the screen, we'll be back in 5 minutes, not 6, but 5. Thanks. I'm back. Just so everybody knows, I am back. Ah, look at that. 10:35. It is 10:34. Okay, so let's see. It looks like people are still with us. I did say 10:35, so I'll give another minute.
These questions are excellent, and I'm going to have to use a little arithmetic.
Oh boy.
But it dovetails with our discussion.
Yeah. Sure does. This is great. Okay, so we're gonna, speaking of questions, we're gonna hit everybody with another question right now. So please, please answer that. I'm gonna be weird. I don't officially have 10:35 yet. Now I do, so I can stop being weird. We have a bunch of questions coming in. Go ahead, the first two I see. Right now, welcome back everyone, with Rich Banta here, and we're talking about EMI and EMP. We're in the midst of a hemp conversation. We went to break, we are now back, and we're just talking about a shield, and the question is, can a shield, including adhesives and tapes, be expected to last the typical 10 to 15-year lifespan of a data center? What does testing and inspection look like over the course of its lifespan? Rich, what do you say to that?
Well, we're going to have to do a little arithmetic here.
Okay.
And it will go into the 19 months of delays in testing we had. It turns out we tried for an impossibly high target for reduction, but the normative standard against which any shield in the US that the DoD or federal government is using is MIL standard 188-125. This document came out in 1993, and one of the founding fathers of EMP theory, Dr. William Rodasky, wrote a 12-page refutation to it after the fact, pointing out its shortcomings. In particular, it used dual exponent calculations instead of quotient exponent. The dual exponents don't lend themselves well to lots of iteration. Even in an Excel pivot table for calculating the different angles of the electromagnetic pulse coming at you and the amount of coupling you'll get. Okay. So if we could pull up the 800-125 or 188-125 slide showing protection.
Okay. And while we're finding that, we got another poll question, as you saw. We have an answer. Does your organization possess the necessary in-house competency to protect your digital infrastructure and people against EMI? And believe it or not, 44% believes they do. 56% believe they don't. So we can spend the next few minutes to try to convince the 44% that it's great that they feel secure. It's great they are competent, which we assume. But explain also what they might be missing. Okay, what the heck's going on with this one?
This is the MIL standard 188-125 requirements for protection.
Okay.
And if we look at this, the frequencies across the bottom, so the vertical scale on the left is dBm. That is how much attenuation this shield must achieve. The bottom is frequency. And this thing was written in 1993. 10 to the 7th is what, 100 kilohertz. 10 to the 9th is a gigahertz.
Mm-hmm.
Yeah, the 1990s called and they want their frequencies back. Yeah, there's very little happening at 1 gig and above back then. And I watched the carriers shoving 400 gig cards into their gear all the time. Yeah. But the 80 dB here is key. And where we ran into our engineering delays, precisely for the reasons the questioner asked, we're going to have some boo-boos in building the thing. We'll leave some gaps, and the materials are going to degrade over time. Now that steel is 10 times hot dipped to make it extra rough for better coupling, which sheet steel so treated will couple better than smooth copper, actually. Okay. All right. And it's not easily going to corrode. Mm-hmm. But we shot for an impossibly high target because, as you know, this is nonlinear. You double every 3 dBm, and we were shooting up in the hundreds and couldn't achieve it. We got to about 103 and just could never get higher than that. So we accept that it's going to degrade, but this is logarithmic. If you have built it to 100, you can have 15, 20 years of a little bit of corrosion, building settling and all that, and still achieve 80 dB of attenuation. Typically, I put the testing question at the end, but I'm going to put it now. So 80 dBm is 100,000 watts.
Okay.
And this is nasty broadband energy, and we're not going to test up to a gig. That's kind of useless in 2023. We're going to test to 10 gig.
Sure.
The manufacturer from whom we buy our line filters and enclosure doors tests to 20 gig. So you have to test this with this nasty, horrible frequency domain of 10 kilohertz to 10 gigahertz. And if to detect a milliwatt of change on the other side, or 3 dB, we're going to have to inject 83 dBm of signal at a minimum, preferably a little bit higher. So we're going to be outside this building radiating 200,000 watts of nasty broadband energy. The building we are eventually going to have to test has cell towers nearby. There's a guard base over at the airport. There are FAA radars over at the airport, and blasting this kind of power into the receivers of those equipment. In fact, there's an AM radio station series of towers in the vicinity as well. This is going to have to be coordinated through the FCC, the FAA, and the Department of Defense to test it. It's going to be nasty business.
So we have a question about the shielding, and the ceiling was clear, but I wanted to clarify whether the shielding extended to the walls. I would expect so, but I wanted to verify.
The shielding is in all directions: floor, ceiling, walls. The generators, any electronics controlling generators or HVAC must be contained and protected within the enclosure. So you have to use external radiators. You can't have variable frequency drive motors with the digital controls going outside. They all have to be free running with spike protection, surge protection at a very high level, separating them all. Anything that you have to have a true dead man for the loading dock and for human entrances. They cannot both be open at the same time. An opening that size completely obviates the shield. It may as well not be there at all. And engine exhaust, engine air intake, makeup air, achieving positive pressurization of the building, etc. Every one of those openings, your fiber entrances, everything has to go through a waveguide duct specifically built to choke at these frequencies.
We so another one of these slides you wanted to show, or
I did want to make clear that if we could bring up a discrete Fourier transform.
Yeah. Okay. So the math.
And this is just for everybody that had engineering school 20 or 30 years ago. This is just to give you your recurring nightmare. But
Right.
to be clear, this is not simple inductive or capacitive reactance. This is time and frequency domain, and all calculations have to be made in and out of that and converted in and out of that. Waiting for the.
Yeah. So we'll tell the producer it's the math ones that came up later today. Is there any pen testing performed after the encapsulation? Did you mention?
The pin testing is the injection of frequencies from the outside to see if you've achieved your minimum of 80 dB attenuation inside.
Okay.
Our materials were tested in a laboratory because obviously with blasting away with those kind of power levels out in the wide open is going to be a trick. It's coming, and I will. I'm prepared to write an addendum to my research paper based on the findings from that.
Right. And again, this is something that's not widespread. But how many people need to be thinking like this compared to how many people have already thought about it? It must be a low percentage that have already thought about it. We can throw another question up too at some point. And also, one of our, there we go, there's another question. Well, yeah, we've actually, that's going to allow us to go to segue, kind of blend into CME. So once we're on the topic of hemp, we kind of, merge into the world of coronal mass ejections. Want to talk about sort of the history. And as I understand it, we're actually in a very active period right now for CME.
We are. We're in a very high solar activity period. And historically, the last direct hit taken centered on North America it's called the Carrington event. It happened in 1859.
Mhm.
And it took out the telegraph system. It caused telegraph papers on telegraph operators' desks to burst into flames. So there is.
People know what was going on then? How long did it take them to figure out what just happened back in 1859?
They found out forensically down the line. They didn't know in real time what had happened. Forensically, they were able to figure it out. The closest thing we've had to a direct hit recently was Montreal did have a pretty destructive event. And the learning experience from that was the solar flare strike was centered over Winnipeg, Manitoba. It interacted with the magnetosphere and the Earth's magnetic fields and disrupted Montreal a few thousand miles away. So that there is still a lot to be learned about those. Wow. We are getting better at predicting those. We have a satellite that shares Earth's orbit around the sun. It leads us by 90 degrees. It's called Stereo A. Stereo B lags by 90 degrees, but it is currently inoperative. And they're using that to gauge from a side view what is headed at Earth. But we are in a very high period of activity that's supposed to climax in about 2024, where this is much, much lower frequencies than what we have with a hemp. A hemp the frequencies are so high, it can couple to a 1/8 inch trace wire on a circuit board. Okay. These are much lower frequencies, 60, 30, and it's actually called near DC. And it's more affordable to defend against in your data center, but it's still something you want to do at construction. It can be retrofit, but you really want to do it at construction time. But it also matters in power substations. So this stuff couples to power lines, and most substations will happily pass it right down the line. In particular, it's called second order harmonics. Here in the US, we're 60 hertz. Europe, Japan are 50 cycle power. Everything is really happy and resonant to pass along 100 or 120 cycles respectively until it gets to your equipment. Then things start blowing up. That can be handled at a substation level by as soon as a common to ground, this creates in the big transformers, it creates a common to ground anomaly. That can be shunted, but the utilities that have done it in the US, I work with 2 utilities here in Indiana. I asked one of them if they are aware of this and dealing with it, and they looked at me like I was from Uranus. Okay. Totally befuddled. I asked another one in a smaller area, and they said, well, of course, we installed that 2 years ago. So it is something good to ask the difference is, rather than what come at you is coupled over hundreds of miles of power lines, all you're going to have to deal with is what was able to couple to those power lines in between you and the substation. Right.
So, but you need to ask that. Are we backing up a bit if we address this question? Since all MEP needs to be within enclosure, how does that impact any DCIM systems? Is that something we can address? You see that one?
We answered the shielding to the walls.
And then below that? Within enclosure? See that one?
It absolutely, if those are connected to your DCIM, if it's hosted in the cloud, if the connection in and out of the building is fiber optic and passing through a honeycombed waveguide, you will be able to talk to your provider if they're still alive, if they still have power, if they're still on the grid, etc. But yes,
that's kind of scary. Yeah,
absolutely.
Yeah. How often will you test it? It says after the first deployment. How do you coordinate complex testing events?
That will be detected by the, it's going to be DoD customers that mandate this, and they have far greater power to affect other agencies and affect cooperation than a lowly data center operator does. So that will be up to them.
Mm. But is there a, so you, it's not a unilateral decision. I mean, it is not really a good specific answer you can give.
No, it's not the operator's decision. It is at the discretion of the using entity, and
Yeah.
the DoD far and away has the greatest interest in this technology.
Okay, so we have about, what do we have? Oh my, about 10 minutes left to discuss this question we just asked about which is a greater source of EMI threat. So one would assume all our threats, we ask people to decide which is the greatest to them, and it comes out fairly balanced. Machine generated EMI, 37%. And the other three about equally balanced: EMP attacks, lightning, and solar flares. So I'm going to take a guess that the CME, excuse me, might actually be a little higher than that now that they've heard you speak about it, about lightning strikes.
That is a completely different protection system.
Mm-hmm.
And we're now in a situation where we have machine earthing for all the machine running in there. We have the shield earthing, and we don't want it to backfeed, but they are tied together at some point. And then lightning is tied to earth. Our goal is to have all the lightning protection external to the building, higher than the building. And oh gosh, I'm forgetting the name of the technology that actually attracts lightning to a pole. A lot of concussions, Coach.
That's okay.
But so we're treating those separately. So these systems only, these three separate earthing entities only connect through the earth. And in Indiana, they use a constant of 25 ohms for our nice moist clay here.
Mm-hmm.
Although Indiana's a fill-in swamp and a lot of it's fill.
Mm-hmm.
That except for at entrance to the building, IEC 70 says that you will tie common to ground at your entrance panels.
Mm-hmm.
So we do worry about a backfeed coming through there. We have a lot of surge protection to prevent that, but it's a lightning strike or an EMP backfeeding into the machine, the ICT earthing system, is a concern. I've lost sleep over it and done a lot of arithmetic. And we arrived where we arrived while still meeting code and life safety.
Mm-hmm.
And also talking this stuff through with local code enforcement, building code enforcement, and life safety has been an experience. We've had people that didn't want to play, that we've had people who realized it was a higher calling, such as the dead man with these big heavy EMP doors. We're still in a situation, if there is an emergency evacuation of the building, there's a chance it's going to be unprotected because the fire marshal says it will be.
Yeah, I'm couple of things I can ask the producer if we could find those math slides that we included.
Oh, that's just to give the engineers flashback nightmares.
We're just trying to traumatize you a little more. But and again, I've been told, we're not here to. Oh, then I found that one to be interesting. You've gone through a lot of this, but this is some of the real particulars.
Yeah, and
of it.
So our worst case, depending on the worst case angle, and this was using my Fourier transforms, running them through an Excel pivot table.
Mm-hmm.
And by the way, if you have a 2-digit negative exponent in the pivot table, there was a bug for quite a while where you had to reboot your machine.
Nice.
Excel would eat itself. But we're looking at 200,000 amps. But remember, we're going to succeed or fail in 25 nanoseconds. If you apply time domain to that, this is where all of a sudden those 368 ground rods, or probably the 80-ish of them that would be affected in any event, are going to have to pass 6,560 amps of broadband ampacity. And there were no ampacity tables out there for broadband that covered that. I finally found construction plans for a UK substation online and downloaded them. In some of my peer reviews, I was asked, where I got such a thing and was told I couldn't have it. I said, well, I Googled it and downloaded it. So we have found a better table, but this, when I talk about this being a nascent science, this stuff just wasn't out there. We had to figure quite a bit of it out as we went.
And again, I was told not to go too heavy on our audits and assessments, but I do have to mention it. We, the IDCA generally, and Rich does get involved in a lot of these, have a variety of audits and assessments to come in. And I heard you mention retrofit. I mean, it sounds as if when you're coming into a facility, you're looking at everything outside, inside, top to bottom, historically, problems they've already had to retrofit. But on a scale of like 0 to 10, what are some of the easier things to address? And what are some of the really, really difficult things to address that people
Obviously,
should be aware of?
Encompassing a facility, floor, walls, ceiling, powerhouses, and HVAC in a sheet steel shield is damn near impossible.
Mhm.
Greenfield building one to be multiple stories is also exceptionally difficult. Some easier retrofits are to install line filters. There is one credible manufacturer of those in the United States, I would say, and we work with them. They're mentioned in my paper, which if you're an IDCA member organization, you can download it.
Mhm.
I reference them pretty heavily. You can add line filters for the high frequency EMP stuff. Much more affordably, you can add very high K factor oversized transformers to block the coronal mass ejection stuff. That does create a second set of problems, which is also discussed in the paper how to work around. And finally, just getting your equipment out of the 2-post racks, putting it in a well bonded earthed cabinet, and individually bonding each piece of equipment within that cabinet. That's considered tertiary protection in a highly protected facility, but it is a good start for first line protection in any facility.
Yeah. And it's something, again, I keep going over some of the same things, but it's got to be a large percentage of facilities where you go in and they really do need something that they may not have. We have one more, I think, time for one more poll question. We're asking if people, okay, wait a minute. I don't remember this question. Well, 100% have said yes. And so I'll say that before the poll even closes. That's literally true. There's no votes here. So we're gonna keep on doing this. We actually do have a series of events coming up. We're going to talk next time on August 16th. So everyone found us, we found you, and we'll be in touch. We really appreciate everybody joining us. If we didn't get to your question, we will address it. There were a couple that we couldn't get to, a few we will contact you personally and address the question for you. And oh no, here's the mandatory, we hope you like this sort of thing. So far, no votes. That's good. On August 16th, we this is the first and presumably right now so far the best of a lot of complimentary webinars we're going to be producing. And Rich may participate in some of the future ones as well. And we do them on Wednesdays, and we do them at 11 a.m. Eastern is when we start them, 11 to 12 Eastern on different Wednesdays. August 16th, we're going to be talking about drivers of digital economies. September 20th, operational excellence. There's a lot more to it than you may think. We're going to do one of these a month. October 18th, I see Rich popping up. He's going to come back on October 18th to talk about mission critical digital infrastructure in government. And there's a few other people on the panel as well. We're going to talk about sustainability in November. And we're going to finish the year off in December talking about the human impact of AI. A lot of AI stuff going on. It affects you operationally And there's a lot of issues there that we have found in our research that people may not be aware of. So we're going to be talking about that. Again, all that information is available at our website. The final question is, they like us. Okay, 100% are in favor of what we did here today. Maybe they're just being nice, but no, that's fantastic. We really appreciate everybody who took the time to come here today. And I always like to leave the last 30 seconds for our guest, for our star. So for Rich, in 30 seconds, what's the one message that you give to people that they can take with them as they leave?
Educate, educate, educate. If you can download the paper and suffer your way through it, skip through chapter 2, that's the math. Again, that's downloadable for IDCA member organizations. And the more you know, for me, the more I know, the more I learn, the more I know I don't know. But I have a lust for knowledge, but this is about knowing. The entire data center industry and the IDCA are about knowledge.
He's being humble. That's the Midwestern self-deprecation that we all grew up with here. It's actually very brilliant. His work is available to all members. As he said, you can find it at our website. Any questions you have, you know how to contact us. One more time, thanks for joining us, everybody. Rich, thanks so much. It's great to see you, and it's great to listen to you talk. And for now, this is it for IDCA. We'll see you. Bye.
Air Force.